This is Dr. D. Govardhan, Professor Emeritus, Department of Aeronautical Engineering, Institute of Aeronautical Engineering. Today we are discussing friction in a ladder. The friction force having so many applications in our daily life, like in ladder, wedge, and screws. The ladder friction today. The ladder is a device generally used for climbing or scaling on the roofs or walls. It consists of two long uprights of wood, iron, or rope connected with the number of quartz pieces called rugs. If the ladder is uniform throughout its length, then the center of gravity of the ladder, generally it is the midpoint of its length. That means somewhere it is acting. Now we have to analyze what are the forces that are acting when the ladder is about to slides in downward directions. In the ladder, generally the ladder rests on the ground floor and keeps other end in a vertical plane, that is called wall. When the forces are acting on the ladder, generally it tends to slides in downward directions. When it is moving downward directions, that is by to be when it moves downward directions, the frictional force is always acts opposite direction of its movement, that is the upward directions. That means at a point to B, if it is representing in B, that is the normal reactions. It is always perpendicular to the surface at the point of contact. Since the point B tends to slides in downward directions, the friction force is always acts in upward directions. Here, which is represented here as FB now. And at A end, since the body B when it is moving in downward directions, the end A is always moves away from the vertical wall. To prevent its motions, the frictional force is acting toward the right side. And so, this is a treated as friction force which is acting at a point A, FA. And the normal reaction is the perpendicular to the surfaces N2. But the ladder generally it will slides downward directions when the person is going up. Assume at a point C, the person is there, at which the ladder about to slides in downward directions. W is the weight of the ladder, which acts through the center of gravity of the ladder. Since the ladder is uniform, hence the center point is treated as the center of gravity of the ladder, where the weight of the body is supposed to act on it. All these forces at A and B at the center of gravity and the weight of the persons all are treated as in coplanar, but they are non-concurrent. Hence, when analyzing the forces, the equations such as sigma fx is equal to 0, sigma fi is equal to 0, and moments created by these forces about any point should be equal to 0 according to the equilibrium conditions. By using these three equations, we can analyze the forces which are acting on a ladder. Here I am showing as the upper end of the ladder tends to slip downwards. Therefore, the direction of the force of friction between the ladder and the wall FB will act upward, shown in a figure now. Similarly, the normal reactions NB react to perpendicular to the plane at a point to NB and so on. Similarly, as the lower end of the ladder A tends to slip away from the wall, therefore the direction of the force of friction between the ladder and the floor FA will be toward the wall according to this figure toward the right side. The normal reactions at the floor here NA is perpendicular to the ground and at NB it is perpendicular to the wall as shown in figure. The weight of the ladder is acting at the center of gravity, the point C. Assume here this is representing weight of the persons, that is W M. When he is moving this along the ladder, it is a point at which it tends to slides downward direction. That means about to slides. It is the equilibrium position. Now, in order to find the forces which are acting on it, apply the equations of equilibrium such as sigma fx is equal to 0. That is, sum of the component of forces which are acting along the horizontal direction should be equal to 0. Sum of the forces which are acting perpendicular to the plane also equal to 0. And the third one is the moments created by the forces at any point should be equal to 0. So, in first case, the sum of the forces which are acting along the horizontal plane equal to sigma fx. One is Fa is acting toward the right side positive and NB is acting toward the left side negative. It should be equal to 0. It is represented in equation number 1. Similarly, the sum of the component of forces acting perpendicular to the plane, that is the y directions, it also should be equal to 0. That means sigma y is equal to Fb, that is the friction force at a point B, and Na, both are positive, and weight of the ladder W2, that is sigma Fi is equal to Na is the positive, Fb is the positive, and weight of the ladder, that is the W, that of the ladder W, and weight of the person Wm, it should be equal to 0 now. And third equations, that is the moments created by the forces at any point should be equal to 0. Since the suitable point is it may be A or it may be B, where it is having two unknown forces. When I am taking Ma is equal to 0, that is moments created by the forces at A is equal to, here I am considering the forces which are tends to rotate the body in a counterclockwise direction at theta positive, clockwise direction is negative. Here F base tends to rotate the body in a counterclockwise directions, hence positive, hence FB. The perpendicular distance, the point of application to the point where we are considering, it is a small b, positive. Similarly, the normal reaction is there. It also tends to slide the body in counterclockwise directions. But the perpendicular distance is h minus of w That is weight of the ladder. Since the weight of the ladder is given now, it is acting. The perpendicular distance now becomes it is equal to L. If it is a theta is there, cos theta now. L cos theta. Similarly, the person where it is there now, assume the distance is equal to L1 minus half weight of the man and L1 cos theta, it should be equal to 0 required. By using these three equations, we can analyze the forces which are acting on the ladder.
Like, share and subscribe. Hit the bell icon for more updates.